Hi everyone, in this worksheet we are going to look at chapter 5, exponential logarithmic functions, worksheet 6. In this worksheet we will learn how do we solve logarithmic equations. So meaning that once I have an equation with log functions, how do I solve it and find the value of x that will satisfy the equation. Okay, so let's now look at the worksheet here. There are two main methods you need to know in order to solve logarithmic equations. Method 1, it's either you make this logarithmic equation into the logarithmic form here, whereby the left hand side is your log function, the right hand side is a number, and then you can convert it to exponential form in order to solve this equation. Or the second part is you can make both sides of the equation one single logarithmic function. Then once you have done that, you can then compare the terms here. So how does this work? Let's see, if you were to make the equation, left side and right side, one log function, same base, take note, same base, then you can compare this m is equal to n. Okay, how does this work? You can simply do a simple proof to understand why this works. So let's start from here. Okay, if I were to have a logarithmic equation like this, how do I get to m is equal to n? The proof is as such. If I were to rearrange the equation, I will subtract log base a n on both sides. This will become log base a m minus log base a n equals to 0. Then by the quotient law, you can apply this to become log base a m divided by n equals to 0. Then from here, if I were to convert to exponential form, this means that my m over n is equal to the base a power 0, which means that m divided by n is equal to 1. And therefore, by cross multiplying, it means that m is equal to n. And that is why if I have a logarithmic function like this, okay, if I'm able to express a logarithmic equation like this, I can straight away compare that these two numbers here, m is equal to n. Okay, and this is how we can solve logarithmic equations. So now we'll look at one important note for here is that, take note, right? When I have a logarithmic equation like this, it doesn't mean I'm cancelling out the log. Okay, the understanding of why we can get m is equal to n is based on this entire proof over here. Okay, if you think of it as cancelling, you will make careless mistakes, because if you note that this equation over here, log base ax plus log base ay equals to log base az, it doesn't make sense to cancel a log like this, because this equation here is not equivalent to x plus y equals to z. Okay, remember, it is not the cancellation of log, but you must first ensure that on the left side and right side of the equation, there is only one log function. Then you can apply this property over here. Okay, so let's look at some simple examples in order to apply and solve logarithmic equations. But also it is also important to note that you must always check for the validity of solutions by substituting your solution back to the original equation. Remember, for any log base, let's say if I have log base a b, okay, the conditions are that these two numbers here, the base as well as this number here, must always be positive. Okay, they cannot be negative numbers. Okay, so let's look at example 1. Example 1, find the value of x for each of the following equation. Very simply, this is, you can use method 1. Method 1 is conversion from logarithmic form to exponential form. So over here, let's look at this. I have only one log term on the left side. I want to convert this to exponential form. I will get x is simply equals to base 2 power negative 1. Therefore, x is equal to half. This is for part A. Okay. Let's look at part B. Part B here. LG, remember, LG is a short form for log base 10. So this means that log base 10, to get 6 minus x, I must have a power of 2, which means that 6 minus x is equal to 10 power 2. Therefore, x is equal to 6 minus 10. 10 squared is 100, so 6 minus 100, I'll get x equals to negative 94. And we know that even though here x is a negative number, this x6 minus x must be positive. So over here, if I make a small note, from here I sub back into original equation to check. 6 minus negative 4, this is equal to 100. And therefore, this equation is valid, because this number here is positive. Okay? Remember, because a lot of students always think that just because x is negative, I must reject. That is not true. This entire expression here must be positive. And in this case here, even though x is negative, the entire expression here for 6 minus x is 100, which is a positive number, and therefore this is a valid equation. Okay, let's now look at part C now. Part C here, I want to convert this to exponential form. I will have, by conversion, I will have, okay, in this case here, to get 8, the base x must have a power of 3 over 2. Okay, so therefore, I want to first find x power half. I take cube root on both sides. If I take cube root of 8, I'll get 2. Therefore, I square both sides from here. X is equal to 4. Therefore, this is the solution to part C. Okay. Let's now look at part D. Okay, remember, I have a ln now. Ln means log base e, whereby e is a natural number. So over here, I want to convert this to exponential form. So this will mean that in order to get 5x, the base e must have a power of log 5. Take note that log 5 is just a number, log 5. Okay, so therefore x is simply equals to e power log 5, the whole thing divided by 5. Press in your calculator, round off to 3SF, you should get 0.402, round off to 3SF. Okay, this is for part D. Okay, part E now. Let's look at part E. Ln x, the whole thing square is equal to 2. So when I want to find what is ln x, I take square root. Take note when I square root any unknown numbers, I must have a plus minus. So this means that ln x is equal to plus minus square root 2. Okay. Then from here, this means that therefore, by convert to exponential form, to get x, the base e must have a power of positive root 2, or e must have a power of negative root 2. Okay, and therefore if you round off to 3SF, you should get 4.11 or 0.243, round off to 3SF. Okay, this is for part E. Alright, so now let's look at part F now. Okay, part F here, log 4x times log 5. Take note, this is just a number. I want to find x, so I make the term with x the subject. I'll get rid of log 5 by dividing log 5 on both sides. So therefore, log 4x is equal to 1 over 2 log 5. I divide both sides by log 5. Then from here, I convert my logarithmic form to exponential form. This is just a number, because log 5 is simply a number. So therefore, to get 4x, the base here, the base log LG means base 10, must have a power of 1 over 2 log 5. Okay, therefore this means that x is equal to 1 over 4, I divide both sides by 4, times 10 power 1 over 2 log 5. Okay, therefore this is equal to, x is equal to, round off to 3SF, you calculate this, you should get 1.30, round off to 3SF. Okay, and with that we have finished example 1. Alright, so now let's look at example 2 now. Example 2 here, solve the following equations. Now example 2 will make use of method number 2. So recap again, method number 2 means I make this logarithmic equation, left side and right side, one single log term. Then I can compare these two numbers. Okay, but you must make sure that they have the same base first. Let's look at example 2 now. All my logarithmic functions are ln, which means base e. Okay, so I can simply combine them. Over here, maybe I can shift these two terms to the right side because they are negative. So this means that ln x plus 3 is equal to ln x minus 1 plus ln x. Then by the product law, I can combine these two ln functions together. This means ln x plus 3 is equal to ln x times x minus 1. I'll put a square bracket to mean that they belong to the ln function. Okay, therefore now that I have one logarithmic function on left and right side, same base is e. Therefore, I can now compare these two expressions together. This means that, therefore, x plus 3 is equal to x times x minus 1. Okay, therefore, now I have a quadratic equation. All you need to do is to solve this quadratic equation. So over here, x plus 3 is equal to x squared minus x. So therefore, x squared, I shift 4 terms to the right side, minus 2x minus 3 equals to 0. Okay, from here, this is my quadratic equation. I hope you remember how to solve quadratic equation. Simply by factorization, I'll get x minus 3 times 2x, times x plus 1 equals 0. Therefore, x equals to 3 or x equals to negative 1. Then now, once I get the solution, I must check that are these solutions valid. I look back at my ln function. Okay, if I put in 3 here, here, all the ln functions are positive. It will be valid. Now negative 1. I put in here, negative 1 plus 3 is 2. Okay, negative 1 minus 1, negative 2. Not valid already. X, here is negative 1, also not valid because, remember, I recap again, all your logarithmic term a, b are such that these two numbers here, a and b, must be positive for log function to be valid. Okay, to be valid. Therefore, in this case over here, since x minus 1, this thing here cannot be negative 1. Therefore, rejected. Okay, rejected as ln x minus 1 and ln x is not defined when x is equal to negative 1. Okay, so from here, therefore, this is how I get the solution to example 2 part A. Okay, now let's look at part B. Part B over here, same concept. Okay, over here, take note that I must have one log function on the left and right side. But one important part which you may not have noticed as well from here, the coefficient of your log must be 1. So if I look at example 2b, okay, over here, before I can compare this, I note that this coefficient here is not 1. So therefore, by the power law, I can bring up this 2. This means that log x plus 2 times x minus 2, okay, is equal to log x plus 3 the whole thing square. Only now I check coefficient is 1, log function on left, one log function on left and right side, same base, which is base 10. Now I can compare this directly. This means that x plus 2 times x minus 2 is equal to x plus 3 square. Okay, then now I have a quadratic equation. You simply need to solve this. So by expansion, I'll get x squared minus 4 equals to x squared plus 6x plus 9. Okay, therefore, by solving, I will simply get 6x equals to negative 13. Therefore, x is equal to negative 13 over 6. Then we check for validity over here. Check valid. I sub in. Maybe I can write a side working at the bottom. Check. Okay. Over here, x plus 2 times x minus 2. This is simply log. In this case, it can be simplified to x squared minus 4. So this just means that negative 13 over 6 square minus 4. Okay, this is valid. Okay, over here, I just need to check the number so I can note that over here, this portion here is more than 0. Okay, next part over here, x plus 3. Okay, I check over here, negative 13 over 6 plus 3. This is also more than 0. Okay, Therefore, this means that x minus equals to negative 13 is a valid solution. Okay, so this can be a side working you can make at the side to ensure that whatever answer that you get, it ensures that this original equation is valid. Okay. Alright, so now let's look at example 3 now. Okay. Example 3 here. Okay, if you were to look at example 3, right, I have log terms over here. Remember, if you want to use method 2, okay, the base here must be the same. So now the difference in example 3 is that, for example 3 here, I have log functions with different bases. I have a base 5 here and base 25. So naturally, because of the different base, maybe I can make a note at the side here. Note these are different bases. Okay, so therefore, what you need to do is to first make the base the same. So for part A, log base 5x, I want to change base 25 to base 5. By the change of base formula, let me write it down in case you have forgotten. Change of base. Let's say I want to change from log base AB to log base C. It will be log base C with a B here over log base CA. This is the change of base formula. So to apply this, I want to change from base 25 to base 5. Okay, this will become log base 5, then the top number, x plus 6 divided by log base 525. Okay, equals to 0. Now I've changed my base. I can now further simplify this. I will get over here, maybe I write over here, log base 5x minus, note that log base 5 to get 25, the power must be 2. So this is simply log base 5x plus 6 over 2 equals 0. Okay, so therefore I can now further simplify. I can shift this negative term to the right side. So this means log base 5x equals to log base 5x plus 6 over 2. Over 2. Okay. Then from here, I will cross multiply to get rid of the fraction. 2 log base 5x equals to log base 5x plus 6. Okay. Can I compare this from here? Remember that to compare, even though they're the same base now, the coefficient of your log must be 1. So over here, I must bring up this 2 by power law. This means that log base 5x squared is equal to log base 5x plus 6. Okay. Therefore, only from here I can now simplify further. Okay, let me make this smaller. Okay, so from here I can simplify further. This means that x squared is equal to x plus 6. Then now I have a quadratic equation. I simply need to solve this quadratic equation. X squared minus 6, minus x minus 6 equals to 0. By factorization, I'll get x minus 3 times x plus 2 equals 0. Therefore, x is equal to 3 or x equals to negative 2. Okay. Then now I check again. I have two solutions. Are they both valid? We take note that in the original equation here I have x and x plus 6. If x is 3, no issue because both these are positive. But if x is negative 2, here become negative even though here is positive. So therefore I must reject x equals to negative 2 as log base 5x is not defined when x is negative 2. Okay, and this is your solution to part A. Okay, now let's look at part B over here. Okay, part B, I have this thing over here. Let's write it out. Part B, I have these two log functions. I note that over here the bases are different. Here is base 3, here is base x. So what my first step should be is to make them the same base. So remember your change of base formula again. Log base 3x plus 2. I change this base x to base 3. number base will be easier to handle. It will be 3 times log base, I change to base 3, log base 3 over log base 3x. Okay, this is by your change of base formula. Then from here I simplify this, I'll get log base 3x plus 2 equals to 3 times log base 3. Remember this is 1, so this is simply 3 times 1, which is 3 over log base 3x. Okay, then from here, what we can do is to make your life easier. What we can do is simply use a simple substitution. I have log base 3x over here. It might be a bit hard for you to see, so what we can do is use substitution. I'll let u be equals to log base 3x. Okay, if you find that you can see this without substitution, that's also fine, but it will be easier to use substitution to visualize this equation. So if I use substitution and I replace all my log base 3x by u, I will get u plus 2 equals to 3 over u. By getting rid of the fraction, I multiply u on both sides, I'll get u squared plus 2u equals to 3. Therefore, u squared plus 2u minus 3 is equal to 0. Okay, so from here I'll get this quadratic equation. By factorization, I can solve this to get u plus 3 times u minus 1 equals to 0. Therefore, this means that u is equal to negative 3 or u is equal to 1. And remember, this question here says solve the equation, means I want to find out what is x. So finding out what is u is not enough. From here, since I know that u is given by log base 3x, this means that log base 3x is equal to negative 3 or log base 3x is equal to 1. So do not just reject this negative number here just because it's u, because remember, powers can be negative numbers. Okay, so over here I simply convert this to exponential form. This means that x is equal to base 3 power negative 3 or x is equal to base 3 power 1. And this means that x is equals to 1 over 27 or x is equal to 3. Then we check back again, is this solution valid? Okay, over here x and x, these are both positive numbers. Therefore, this solution here will be valid. Okay, so don't need to reject any answer here. And this is for example 3 part B. Okay. Alright, now let's look at example 4. You can try this by yourself first if you want. Then you can simply pause the video, then play this video to continue watching. Okay. Example 4 now. I have this equation, log base 3x. Oops, let me write my x properly. X equals to 4 plus log base 27x. Okay, so always remember, when you see different bases, always make them the same base. Smaller number better. So over here 27, I can make them base 3. Especially since 27 is a power of 3 as well. So log base 3x is equal to 4 plus log base 3x over log base 327. This is by your change of base formula. Then I further simplify this. This means that over here, log base 3x is equal to 4 plus log base 3x over log base 327. To get 27, my 3 needs to have a power of 3. Okay? So over here, this means that in order to get rid of the fraction, I can multiply 3 to the entire sides of both equations to get rid of the fraction. This means that 3 log base 3x is equal to 12 plus log base 3x, because I'm multiplying 3 to both sides. Some of you may make careless mistake, write this as 4. Remember, when you multiply 3, you're multiplying to the entire right hand side. So all the terms must also multiply by 3. Okay, so over here, therefore, I further simplify this from here. I will get, this will give me 2 log base 3x equals to 12. Okay, I shift this, I subtract both sides by 1 of log base 3x. I'll get this. And therefore, this means that log base 3x is equal to 6. Okay, Therefore, convert from logarithmic form to exponential form. This means that x is simply equals to 3 power 6, which will give me 729. 729. Okay, and with that, this is the solution to example 4. Okay, so now let's look at example 5. Example 5, simply you want to try by yourself, you can just simply pause the video. Okay, for example 5, find the value of x for which this log function for log base 4 is minus what is equal to this. Okay, so very simply over here, I note that all these different logarithmic functions have different bases. Okay, so over here, very simply, the logical first step to do is to simply make them all the same base. Okay, so over here, what I'll do is to make them all the same base. We think of a nice number. 4, 8, these are all powers of 2. So the easiest base to choose over here is simply base 2. Okay, so over here, log base 2, x squared plus 5x over log base 2, 4. Okay, this is your first term here. I change base to form to get this using our change of base formula. Next thing, log function here, I change base in order to get base 2. I'll get log base 2 x power 3, the whole thing divided by log base 2, 8. Okay, and over here, this whole thing is equal to 1 over log base 3, 4, I change to base 2, I'll get log base 2, 4 divided by log base 2, 3. Okay. Further simplify everything from here. Okay, I hope you can see how I get. This will give me log base 2 x squared plus 5x over log base 2, 4 is simply 2. Okay, this is 2 minus away log base 2 x cubed over, this is simply 3. Log base 2, 8 is 3. And over here, okay, I hope you can see that maybe I write this part at the side. This is actually the same as 1 over log base 2, 4 over log base 2, 3. You can see this as simply 1 divided by log base 2, 4 over log base 2, 3. Okay, and what you learn in primary school, when you see a divide sign, you can use KCF, keep, change, flip. So this is 1 times log base 2, 3 over log base 2, 4. And therefore, this entire expression here is simply the same as log base 2, 3 over log base 2, 4. Okay, I hope you can see how I get from here. This is the same as this. Okay, and therefore, I know that log base 2, 4 is simply 2. So from this part here, this is simply log base 2, 3 divided by 2. Okay. Then my last step, not the last step, but I see many fractions over here. Let's find a way to get rid of the fraction. I multiply both sides of the equation by the lowest common multiple of 2 and 3. In this case, which is 6. So I'll multiply both sides of the equation by 6 to get rid of the fractions to make your life easier. This will give me, the first term will become 3 log base 2 x squared plus 5x, okay, minus away 2 times log base 2 x cubed equals to 3 log base 2, 3. Okay, then from here, I continue to simplify this from here. Okay, this means that log base 2 x squared plus 5x, the whole thing power 3. Okay, over here is a negative term, so maybe I shift to the right side to make my life easier. Okay, this will simply give me 2 log base 2x cubed plus this 3, I can simply use power law to bring it up. Okay, log base 2, 3 cubed. Okay, therefore, I simplify further from here. Maybe I minimize this so that I got more space. Okay, so from here, I continue to simplify. Log base 2 x squared plus 5x, plus 5x, okay, I don't know why this is hanging, okay, wait, let me, okay, plus, okay, so over here, log base 2x squared plus 5x, whole thing power 3 is equal to, I shift all these coefficients up so that I can use the laws when the coefficient is 1. So this is log base 2x cube the whole thing square, okay, plus log base 2, 3 cube is 27, okay. So very simply, this means that on the right side, log base 2 x squared plus 5x is equal to log base 2 x power 6 plus log base 2 27. Further simplify, this means that log base 2 x squared plus 5x, the whole thing power 3 is equal to, by product law, since coefficient is 1 now, I can combine these two log functions with the same base 2. This will give me log base 2 27x power 6. Okay, therefore from here, now I can now convert from exponential form from logarithmic form to the equivalence by solving this equation. Okay, this means that over here, therefore, x squared plus 5x, the whole thing power 3 is equal to 27 x power 6. So therefore, to find x squared plus 5x, I simply need to cube root both sides. Cube root of 27 is 3. Cube root of x power 6 is x squared. So this will give me 3x squared. Okay. Therefore, this means that over here, 2x squared minus 5x is equal to 0. Therefore, x times 2x minus 5 is equal to 0. By solving this equation, I will get x is equal to 0, or 2x minus 5 is equal to 0, which means that x is equals to 5 over 2. Okay, then I'll check again. Are these both answers valid? X equals 0 and x equals to 5 over 2. I check back over here. Remember, I have this part over here. Remember, this number here must be strictly positive. There is no number that you can power to get 0 over here. So when x is equal to 0, this function here and this function becomes 0, and it is not defined. So over here, I have to rejected, x equals 0 as log base, we check the original question, log base 4 x squared plus 5x and log base 8 x power 3 is not defined when x is equal to 0. Okay, and this is for example 5. Alright, so now let's look at the last example of this worksheet. Okay, example 6. Express this logarithmic equation here as a quadratic equation in x, and explain why are there no real solutions. So very simply, to express this as a quadratic equation in x, we rearrange this equation here. So I have, let me write out 2 log base 2x minus log base 2x minus 4 equals to 3. Okay, so over here, I will simply, to make my life easier, I can simply shift the negative to the right. In terms of negative, I shift to the right side. So this will be log base 2x squared equals to log base 2x minus 4 plus 3. Then now I want to combine the terms together. 3, you can make it as log base 2, 2. Okay. Therefore, now this is simply equals to log base 2 over here x squared equals to log base 2 x minus 4 plus log base 2 2 cubed by power law. Then now I can combine together the right side terms by my product law. Log base 2x squared is equal to log base 2, 2 cubed is 8, so 8 times x minus 4. Okay. Therefore, this means that x squared is equal to 8x minus 32. Okay, so therefore this means that x squared minus 8x plus 32 is equal to 0. Okay, and from here, I have now obtained a quadratic equation. How do I show that a quadratic equation has no real solutions? This goes back to the discriminant of this quadratic equation. If you still remember, for this to be, in this case, for this quadratic equation to have no real solutions, the discriminant must be less than 0. So let's check that. Discriminant is simply b squared minus 4ac. I sub in the ABC from here. I will get negative 8 squared minus 4 times 1 times 32. Okay. Okay, over here, what will you get? Let's calculate that out. It will be 64 minus 4 times 32. I'll get negative 64, which is less than 0. So therefore, there is no solution for this quadratic equation, and hence no real roots. Okay, this is for part A, to explain why this quadratic equation has no real roots. Okay, now let's look at part B. Let me shift this to the side here. Okay, part B, make it a bit smaller. Okay, part B, given this logarithmic equation here, let's write that out. Express y as a power of x. So over here, very simply, let me rewrite this equation here. Log base xy, the whole thing square, over log base yx plus 8 equals to 0. Okay, over here, how do I express y as a power of x? Very simply, you note that the bases are different. So therefore, in order to do anything with them, the base must be the same first. So let's maybe change the base to all base x to make our life easier. So this is simply log base xy square. The denominator here, I change to base x. So this will mean log base xx over log base xy plus 8 equals to 0. Okay. Therefore, this means that, maybe I minimize this later. Okay, log base xy, the whole thing square, divided by 1 over log base xy plus 8 equals to 0. So I further simplify from here. Okay, this is a bit long. Okay. So from here, I continue to simplify. A numerator divided by 1 divided by this just means that this will multiply to your numerator. Okay, so this will give me log base xy, the whole thing power 3 plus 8 equals to 0. If you are not able to visualize this, let me work out a small working at the side. In case you don't understand why, this thing here is equal to log base xy, the whole thing power 3. Okay, guys, I think some of you may get confused. Let me write it over here. Okay, this part here can be seen as log base xy, the whole thing square, divided by 1 over log base xy. So by KCF, this means it's log base xy, the whole thing square, times log base xy, which will give me log base xy, the whole thing power 3. Okay, so over here, I'll get this. And very simply, how do we solve this cubic equation? I can simply shift this, subtract 8 on both sides of the equation. Log base xy, whole thing power 3 is equal to negative 8. Okay, remember, if I can cube a negative number, so this means that log base xy is equal to negative 2. So therefore, this is my logarithmic form. Convert to exponential form, y is simply equals to base x power negative 2, which means that y is equal to 1 over x squared. Okay, and with that, we have finished example 6. So now please try the practice questions as practice from what we have gone through in this worksheet on how to solve logarithmic equations.